Hey everyone, and welcome to another video. My name is Elric, and this is the first video in the Microsoft preparation / refresher for exam 70761. Just a disclaimer, because the intro sounds a little weird. I do not work for Microsoft. I have no affiliation with them other than I did recently take and pass this exact test. So, right into the video. Actually, first, I'm going to get this out of the way. In the description, there's a download link for Create Scripts 001 and Tutorial Scripts 001. Download those, or pause this video, download those so we can work together, or, just follow along. Also, in the description, there should be minute markers so you can skip. I wouldn't really suggest skipping a lot of the stuff unless you're really confident about this specific subject area, especially when there are some uncommon things in here, especially like value persistence and select versus set, getting null values, and there's also ways to break. It's just not, this is how you do it. Best case scenario, it's like, all right, this is what you're going to look for because, you don't have your IntelliSense when you take the test, and that kind of sucks. So yeah, another thing to get out of the way, like, comment, subscribe, especially comment if you feel that I missed something. Comment. Also in the description, I will put a section, so I will take your comments and put them there, cite you, all that good stuff if I miss something, or I will reply to you and say, hey, I've reserved that for a video revolving around X. Because I'm not going to go over order by or having or stuff like that. I'm going to save that for a window or a aggregate function video. So yeah, like, comment, subscribe, help me out, do the good stuff, and download these scripts. So here we go. This video, we're going to go over a little bit about aliases, select versus set, and from. Here's kind of the breakdown of what we're doing. And the first thing I want you to do is copy this area. This will be a common theme where I'll give you something to copy so you can paste it below. So aliases, pretty simple. You can declare aliases in two different ways. And as you can see, I'm just kind of selecting a static value. You can use as to declare an alias, or you don't need to actually say as to use an alias. One of the things in the exam is that follow directions. Like, it's going to tell you what to do, how many letters to use in your aliases, all that stuff. So it's very important to follow directions. When it comes to aliases, sometimes reserved keywords do work, and other times reserved keywords do not work. So even with the as, we still get an error. So that's stay away from reserved keywords and you'll never run into this error. Also, aliases cannot have special characters in them, and they cannot begin with a number unless you either wrap them in square braces or brackets and or single quote your alias. Best practices, just avoid all this. There's no reason to add special characters. Let me do this instead. There you go. I'll save that. Yeah, and it kind of breaks normalization when you think about it. You're required to always query the data in a specific way, which is not what normalization is for. So try to stay away from special characters or beginning aliases with a number. Just try to stay away from needing to wrap anything in square or single quotes. Name parts. Here's a nice example. So a name part of an object, as you can see, we have server, Microsoft certification, which is the database, the schema, and then the table object. If we run this, you'll notice that it's in reverse. Well, for me, being American, I read left to right. So this is actually 1, this is 2, 3, and 4. So when I go backwards, I actually get the server database schema and table. Parse name is a really fun function, and you can parse IPs with it. But just wanted to go over name parts because, once again, follow directions. So you can use the full for name part while you're selecting from a table, even if the table does not have that specified. For aliases themselves, I do not like abbreviated aliases because they don't really make any sense. I like to use the actual object name as an alias. It helps me identify exactly what table it's coming from. And I actually declare the alias with the object name and not, remove this and use the object as the alias, because there's a big difference between the two. Yeah, it just doesn't make sense, but you can do it. And you will be doing it. So, a little best practices thing, in my humble opinion. So, selecting data without assigning it to a variable instead of like select variable equals, you can, you have your string, your n string, your nvar, integers, floats or numerics, and even var binary. It's really important to understand that this is not var binary, it's text. That's how we'll read it as. You don't need to wrap var binary in a string to use it. And you do need to wrap your strings in single quotes, or else it'll think it's a column. Which is weird because later on when we're calling a stored procedure, you don't always need to say that this is a string, and it blows my mind how it still compiles. I don't understand, but whatever. We can assign a variable, like we can declare and select the variable at the same time. Oh. This is where that paste comes into play. Yep. I should have done this. Just to show that we can declare and assign the variable at the same time. We can do it after also, and it is permanently assigned until we assign it again. We can also nest as far as we want without requiring an alias. So we can select the variable in parentheses and just keep nesting as far as we want. Yep, simple mistake, trying to use a variable that was not declared, and IntelliSense will highlight that for you. So set versus select, the assignments are the same. Set and select have several similarities, but then they're different in other cases. So let's do this. After, post declare assignment, they basically look the same. You're just interchanging the word set for select. You can, like in this case, let's see, I have my select down here. Nope. Sorry. We can declare and run and pull a single value from a nested query and set and select them the same way. Save that. We can also do this directly from a table. I really dropped the ball on this. I apologize. I'll try to go over this a little bit better next time. So yeah, we don't need to call it from a subquery basically, or assign it using a subquery. We can assign it directly from the table. We can also, knowing that this table has more than one value, we can push more than one value into the assignment, but we're not going to get what we expect. We actually get the last value in in the table. The a table is basically defaulted. The default order of a table is dependent on the cluster index. So that's how you know what variable you're going to get. If we do top, it's going to be that last record out. Just think of it as because behind the scenes, SQL is a giant cursor. It's doing row by row operations. So think about it in set theory if you want. We are not at that level in electronics to actually perform set operations. All it is a cursor underneath. So it's assigning each row one at a time to this variable, and then end of table, last row, that's the value you get. You can, and this is pretty interesting, you can set both variables at the same variable with two different columns. And the same thing kind of happens. Not only do you get the last record, but you get the last declared column. So if we were to flip this around and run it, it should make a little bit more sense. You still get the last record, or you still get the record. I just realized that I limited this value. But we can make this mistake. We can assign the same variable in the same select statement to two different columns. So the preference is the very end, no matter how far down we go. We can nest, and I'll go over some mistakes here in a moment. We can select two columns and then one column out of it through like a double nested. What we cannot do, as you can see, when we're using the from, we must declare an alias. Let me drop this down. That's the only difference between these two statements, is this one does not have the alias, and this will not compile. Once we use the from with a subquery, we must use an alias. So it's just something to keep in mind. Set does not work like select in this case, where we're trying to set from a table. If we are trying to assign variables using a table, we must assign every column a variable that we are returning. This will compile if we remove date from it, but if we allow date to remain here, I mean, even our hint says that, you must assign every returning table, a returning column, a variable if you assign one of them, all or none. Multiple records into one variable. So unlike the selecting or assigning a variable from a table in this sense, ignoring the word set, we can use a subquery to do so. However, even though it compiles, when actually ran, it will error out because more than one value is trying to be assigned here. That's a difference between the two ways. So going over persistence, let's see. Okay. So if I declare my two variables, I'm going to use the table method. On my set, I'm going to set these with known value, or on my select, my set, I'm going to use the only way that I can. So basically, just assigning a single record to the select and set variables. Now, if I go back through using the same method and I assign them to values that I know are not there, we get a persistence issue. So the select held on to the value even though we know that there is nothing being returned. It's just how it handles this specific execution. So to get around that, a very easy way, two of them, before we assign it the second time, I usually like to null out my variable because I work with cursors a lot. Instead of using joins to allow the SQL Server to optimize my query, I use cursors so I can optimize my query. It's a long conversation. I should make a video about it one day. Another solution is that same functionality does not happen when we use a subquery to assign a variable. Let me just copy this to show you what I am talking about. Actually, I'll do it right here. The easiest way is if we comment out the select statement the select from table and use a select in this fashion, it actually performs like the set. It's getting the, what's going on? Oh, that's what's going on. It will null out the variable because the subquery is actually evaluating as null versus an empty record set. So that is probably the better solution. I just don't really like using subqueries, but that's a personal preference of mine. I mean, subqueries in that way. And that is it for persistence. Very important, especially in the real world, to avoid these kind of errors, because that's a couple hours bug hunting to see what's going on, depending on how big the system is. So selecting from, absolutely, you can use star to get all of your columns back. Mixed feelings. I would not do this, but if you're ad hocing it, just doing it to figure something out, there's no reason not to. Just remember that every column that you get back, select star, even in an exist statement, that's all the data that's coming back. So it's better, especially in an exist statement, just to do select one, get the lowest imprint possible, just not returning all of that data. Another obvious way is just limit the columns that you are selecting. You can do something where you can select something from a table, comma, another table, and this is called an implicit join. You basically use the where clause as your on clause, and this is an implicit join. It's very important to understand between implicit and explicit. Explicit meaning that you are explicitly defining the type of join that you're using. It's really interesting. Both of these two statements return the exact same results, and they have the same query plan. So with the implicit join, you use the where clause. And these are, is it same data set? Yep, same data set, two different execution plans. I do suggest kind of looking at the execution plans on a lot of these statements just to see what is happening in that extra step. That's one of the biggest things, and I'll cover that in the next video about joins, about the where clause versus and how we can optimize these statements, or optimize joins better if you choose to use them. So another item, do I still have this? Yes. Okay. So we can stuff a variable without actually using the aggregate stuff. So from the table, I'm basically just pulling a column and adding a comma to it, and I get back a comma delimited list. Neat little feature that you could do. That's if I initialize my variable as an empty string. If I never initialize my variable, I mean a null plus 99% of things is a null. There are a couple of join operations that we will cover that you will see handles nulls without any specific is null, coalesce, IIF, case, statement, and we will handle null handling in another video. So with using this same kind of setup, we want to get a comma delimited list. I'm actually going to run both of these at the same time. Adding the word distinct before it, we do not get what I would expect. I would get a distinct list, but the sorting happens. The distinct is processed last. So the distinct is essentially ignores the assignment. So it's creating this, and that's not going to work. Do this so you can see. Yep. So it's clear. The distinct is ignoring the assignment variable, and it's creating a list like this. And this is the last record. So we're kind of getting a mix and match of the multi-record assignment to a single variable. Even though, we were able to kind of create that comma delimited list. So there are some very weird things about the firing order on some of these statements. Kind of important thing to understand is just the distinct is processed before an assignment. And I bring distinct, there we go. We're gonna get into hints. So what the distinct does is basically just gives you the unique columns back, and it's fired. What would be the order? I guess it's just fired right before assignment. And before sorting. Before order by. But the distinct is also, it's not limited to one column. So you call multiple columns back. At first, our first distinct statement, we only got 3 records back because it's the distinct date, but when we add another column, it takes the uniqueness of both of these values added together as if they were strings. You cannot do something like this. Distinct has to be right after the select, even when adding other hints like top or with ties. Distinct has to be right after the select, period. So this will not work, nor will it produce an expected result that this might be looking for. Top just returns the top 3 items. Once again, default order of a table is by the cluster key or the clustered index. So we just get our top 3 here, ascending versus descending, just different results back. So you can see 3, 3, and 2 to know that top is not, does not distinct the list, does not create a unique list and return it like some of the later statements will. You see that we wrapped them in parentheses. You do not need to wrap the numeric in parentheses. And top also has a percent, knowing that we have 4 records. Top 75% would be 3. Same thing the opposite way. Percent is not does not distinct the list. You can declare a variable and use the variable in your top clause. As you see, we have let's see, top 3%, top 75%. We can remove this percent and run it again. Top 3, top 75%. I'll cover offset and fetch in the window and aggregate functions video, or the aggregate. I'll do window in the window video. Simple mistake: using a variable without the parentheses does not work. Distinct not being first does not work. So with ties has been around since 2008, but it's kind of an uncommon thing. So what with ties does is it gives you your top 3, but then because the third value is tied with something else, it's going to return those values. And it's dependent only upon the order by. So selecting the same item back, ordering by a numeric float, another value, we get a very different order, but it's numeric. Let me get this in here. Oh man, it's too cold today. So the numeric value did tie for last place and it's returning it. So it's not, you can't think of it as the column that I'm selecting is tying. It's actually only based on the order by statement. So if we ordered by float ascending, which is this, and date descending, would flip this around, we don't get the same results back. So it's very interesting thing. I could see it being used in analytics. Like, give me, top 50% with ties, this data set to feed in as a training set. So ties is just a very interesting item. It extends the top out to values that match when the limit is hit based on the order by statement. I would definitely recommend spending some time to experiment with this with ties item. So moving on, selecting from functions. Yep, pretty easy. We can select from a function, pass it a value. We cannot set in that way. We can set and select the values in the same way, and just for demo purposes, we do get the same values back. It does work in the same way. We cannot select table value functions in the same way we can select scalar functions. We need to treat it as a table, select star from that function. We cannot select star from a scalar function. We cannot left join a scalar function. Let's see. Hope that's fair. When pulling from a table, yep, we can assign a specific value and get that repeated result. We can send a variable coming down, get that repeated result, and we can even send a field from, I mean, pretty standard, sending a field from the, or a column from the table that we are selecting from into the function. This is not considered a fast solution. However, there are some times where you just need to do this, and we'll cover that in the apply. It just makes sense. But for the most part, like I said, the SQL engine is a giant cursor, so you are executing row by row things. It would be better to, especially if you're getting the same values back, it would be better to get that value first and just have a static variable up here, which I did not show. Dang, that kind of sucks. You can select a static variable in your select statement. There, I showed it now. But most of us probably knew that. Yeah, so not really BP, but at the same time, there are reasons that you need to do this, especially for specific conversions like custom calcs. If you're not doing a data-driven calc engine and you have a specific function, maybe you need to process every single row the same, and in that case, this is a perfectly fine solution. We can use functions in a where clause. We can send columns from our from statement into a function in the where clause. We can statically define it, and we can also send a variable to our where clause. Save. A better way to treat functions in the where clause, once again, not really best practices, is if you know the value that you are supposed to be getting, you might as well just declare that variable and use that variable in your where statement. So you can create an implicit join from a wow, what's happening here? Oh, that is awesome. So I just learned something right now. I just kind of wrote this without testing it. Let's see how this works. Sweet. So this is trying to cross apply. That is fantastic. Can't do that with an implied. Wow, so look at that. I just kind of wrote these out saying, you know, this is what I'm going to try to do. I did not realize, because I don't use this comma delimited table or comma delimited from statement like this. This is trying to execute something called a cross apply, which we'll go over in the next video. And because there are no results coming back from the values that it's trying to match on, it's trying to match on the same named column. We're not getting any data back, even though we know for sure that we're getting data back from here. And this, see, we're not getting any data back. So it's trying to cross apply it, different from outer apply. So what should we do to get data back? So let's see if this works now. There we go. Interesting. As you see, sometimes you just don't use things, and you learn every single day. So like I just tried to do up here with a comma delimited, you cannot pass a comma or a column down into the function. You cannot cross join, a column down into a function, but you can cross apply a column down into the function. We will be covering cross versus outer in great detail in the next video, but just to, inner and outer joins, basically the two types of joins that you have, the two types of horizontal joins that you have. An outer apply is a left join, and a cross apply is basically an inner join. If it's not getting any values back for the ID that's passed, you will not get that result back, which is why this wasn't working the way that we expected it to. We weren't getting any data from the second data set, therefore it was ignoring the first data set. Pretty interesting stuff. So that is it for the select, as and from and set piece of this video. The next video we will be going into great detail about the, I believe, 8 joins, which are the left outer, right outer, full outer. Let's see, our inner join, our cross join, our cross apply, outer apply, union, intersect, and accept. So that will be the next video, and that will actually, I really like that video because not many people know there's cross join, what it does. That actually is compilable, and cross apply and outer apply isn't used as much as it should be. So thank you once again for watching. My name is Elric. Again, like, comment, subscribe. Add a comment if you think I missed something or skipped over an important part, and I will include it in the description. Thanks again, and you guys have a good one.